The VAWT-X energy technology was initially developed in the UK by a guy called Michael Blaze, who was an expert in aerofoil design with Formula One and later moved on to design of large wind turbines. He wanted to develop a vertical axis turbine because he saw the potential for greater efficiency. I saw the potential for this technology and purchased it in August 2018, and since then we've proven the design. There's been 1,600 hours of simulated testing. We're at the stage where we need to produce physical prototypes for verification of the simulated testing and certification.
The VAWT-X technology is very efficient. This vertical axis technology is proven to have the same efficiency as the horizontal, where I couldn't find any other vertical axis that has the same capability and capacity in transforming the wind energy into electrical energy. The biggest hesitation for the horizontal in turbines is they make noise. This vertical axis technology is more silent, they are more environmental friendly, and it's my individual opinion that they're more beautiful when they're working actually.
The International Renewable Energy Agency has predicted that in fact wind energy will account for 35% of total energy production by 2050. The benefits of vertical axis wind turbine technology, or VAWT, over horizontal axis wind turbine technology. VAWT don't need to be in wind farms, so it opens up a whole new market for wind energy. The achievements so far of the cooperation with Flinders and VAWT-X are that we've been able to produce a 1/5 scale model of our 6 kilowatt turbine. We've also done the initial development of a digital twin. Development of a digital twin is important because it enables us to streamline the design process, so we get to a prototype virtually that we're satisfied with before we go to the cost of producing a physical version.
Now we have a testing rig that we can choose the wind speed we want to put through the turbine, and we can get variable data that we can then use with our digital twin.
The digital simulation has involved essentially taking the turbine itself, looking at the physics behind it, and then using that so that we can make an estimate of how the turbine can perform.
The world is moving towards renewable energies, so my contributions have led to a full parametric blade design being done digitally, and we have a fully working physical prototype as well.
One of the most viable application of this technology would be for clean hydrogen production, which, given that we have enough wind around here, enough water around here, we can easily use that for that purpose.
So there are a number of applications for this technology. It can be used along transport corridors such as electrified rail, motorways, even on top of the national grid. It can be used in agribusiness, the mining sector, in the oil and gas sector, offshore energy generation. If we want to get really innovative, we can turn these turbines upside down, place them in water and generate power from tidal flow. The applications of this technology are really only limited by our imagination. Our long-term goals are to set up a manufacturing facility here in South Australia, focused not just on the 6 kilowatt, but on the 80 kilowatt turbine, where we see that there is significant potential in terms of application on an industrial scale. If you want to find more detailed information about our turbines, go to our website. You'll see information about specifications, performance and cost.